Okay, so when I say, let's say 10 factorial divided by 8 factorial, you can do this. You can go 10 times 9 times 8 times 7 times 6 times 5 times 4, 3 times 2 times 1. And then underneath that you can write 8 times 7 times 6 times 5 4 times 3 times 2 times 1. And the 1's cancel, 2's cancel, 3's cancel, 4's cancel, 5's cancel, 6 cancels, 7 cancels, 8 cancels. And then it is 10 times 9, which is 90. You can do that. That will be silly. You can also do this. 10 times 9 times 8 factorial, or 8 factorial. Do that. Okay? Because you'll get the same answer, which is 90. So factorials can reduce off. Basically, that's what I'm trying to tell you. Okay? And you have those 6 problems. I want you to do those also. Now, on your calculator, there is a button, and my calculator is different than yours. Okay? And I'm going to show you what the button will look like. So let me go to my algebra. I believe that's where it is. Nope, it's in statistics of mine. So I go down to probability, boom, and I get that. And you should see a button that looks like that on your calculator. See if you can find it. Just like surprise. It's the surprise button. Do you have one? No? No surprise button? Do you have a probability button someplace? Okay? Push that. See if you get a surprise. Alright. You're surprised. If there... Yeah. We'll get to the NCR NPR. Okay, if you just go 10 and then hit the surprise button after that, and you're going to get that, and that is your 10 factorial. Okay? So if you haven't found your surprise button, I will come and help you. Yeah, shocked and surprised. Now, this is NCR. For example, let's say I'll make one up. I'm not going to do one of those. Okay, let's say I have a 10 factorial over 7 factorial times 3 factorial. This is known as a combination. Okay? This is also written as 10 choose 3. 10 choose 3. This means same thing as that. And of course, this means same thing as 10C3. 10 choose 3. Okay? So that is your NCR button. NCR button. So, if you go find your NCR button someplace, it's probably in, again, in probability. Okay? My NCR button's here. So what you will have to do is you'll have to punch in 10, and you'll probably have to punch in NCR button, and then you have to punch in 3. That's what you probably have to do in your calculator. Here, I'm going to find that 10 parentheses 3 with the graphing calculator, and I'm going to hit enter, and you should get answer of 120. If you got answer of 120, then you did it correctly. I'm going to connect the dots for you. I'm just showing you how to find in your calculator. Yes. What happened to 7? Poof, disappeared. Everything's going to make sense in a second. Okay? I'm just showing you how to find those buttons right now. Okay, how to do factorials. One thing at a time. Rome was not built in one day. Okay? Alright, here we go. Now comes the binomial theorem. Okay? Let's say you have a binomial expansion x plus y to, let's say, n. And n could be any number. N could be 1 million, n could be 100,000, n could be 10. It doesn't matter. Okay. Your binomial theorem says you're going to have x to the n power plus, because that's the highest power x is going to be, plus, then x goes down by how much? 1, so it'll be n minus 1. And then y comes up by 1. Leave a little space there. Plus. Okay? And then x goes down by 1 more, therefore it will be n minus 2. And then y will be the power of 2. Plus. There's going to be a little space, and now x will be to the power of n minus 3, and y will be power of 3. Well, this is getting kind of old, so let's come up with a general formula, and that will be n minus r to the y to the r. The second number is represented by using r. And then plus dot, 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 and the very last one is going to be y to the n. Do you see why you get y to the n at the end? Because the first term disappears completely, and the second term becomes y to the n, because you started with x to the n. Are we good so far? The pattern of the exponents? Okay. Now, coefficients we got last time by using Pascal's triangle. But there's an easier way. The coefficient of each one of these is going to start like this. This is going to be n factorial, all that over n minus 1 factorial times 1 factorial. This will be n factorial over, where am I getting the bottom numbers from? My exponents. N minus 2 factorial times 2 factorial. So what do you think this coefficient is going to look like then? Third one. N factorial over n minus 3 factorial times 3 factorial. And this one will be n factorial, all that over n minus r factorial times r factorial. Okay? This right here, n factorial over n minus r factorial times r factorial is same thing as NCR. Okay? Alright. If you have 10 factorial, let's say 10 choose 3, then that would be 10 factorial over, what's 10 minus 3? 7 factorial times 3 factorial. That's where you get the numbers from. Okay? Okay, that is your binomial theorem. You will need this to prove the derivative. Okay? Because what you're going to do is, next year, you'll be asked to prove, right, Bree? If f of x is equal to x to the n, then f prime of x is equal to n times x to the n minus 1. To prove that, you have to take a limit as h goes to 0, f of x plus h minus f of x, which you've seen before, over h, and when you plug it in to this becomes limit as h goes to 0 at x plus h to the n minus x to the n, all that over h. And when you take this limit, you will have to expand this binomial, and this will simplify to n times x to the n minus 1. And this is a theorem for the derivative. And that's why we have to learn that today. Okay, having said that, we're not going to prove a derivative today. We're just going to expand binomials. So let's go x plus y to the 10th power. Alright, here we go. I'm going to go fast. Ready? X to the 10 factorial, plus 10 factorial over 9 factorial times 1 factorial, x to the 9th, y to the 1st, plus 10 factorial over 8 factorial times 2 factorial, x to the 8th, y to the 2nd, plus 10 factorial over 7 factorial times 3 factorial, x to the 7th times y to the 3rd, plus 10 factorial over 6 factorial times 4 factorial, x to the 6th, y to the 4th, plus 10 factorial over 5 factorial times 5 factorial, x to the 5th, y to the 5th, plus 10 factorial over 4 factorial times 6 factorial, x to the 4th, y to the 6th, plus 10 factorial over 3 factorial times 7 factorial, x to the 3rd, and y to the 7th, plus 10 factorial over 2 factorial times 8 factorial, x to the 2nd, y to the 8th, plus 10 factorial over 1 factorial times 9 factorial, x to the 1st, y to the 9th, plus y to the 10th, and there it is. It's just not cleaned up. What I've done is I've taken x plus y, multiplied by another x plus y, multiplied by another x plus y, multiplied by another x plus y, using distributive property all the way up to 10 of those. And when you do that, you're going to get this. All right? Now, having said that, I want you to now notice the patterns. Okay? And that's all this class is about, noticing patterns. Now, here's one of the patterns. The top number always represented by whatever the power of the binomial you're going to raise to. Okay? The power on the x goes down by 1, power on the y comes up by 1 each time. Okay? And the other thing is, the bottom numbers on the coefficient come directly from the powers. First term, second term, third term, fourth term. In the fourth term, what's the power on the y? 3. In the fifth term, what's the power on the y? 4. In sixth term, the power on the y is 5. So that means you can logically say the power on the y will always be 1 less than the term that you're trying to find. Got it? Okay, here we go. Let's say I have x plus y to the 1,000th power. And I want you to find, okay, 401st term. Okay? Well, you don't have time to write out all the terms to get to 401st term. But we know one thing, y will have a power of what? 400. Then x, that will tell you exactly what x has to be. X has to be what now? Which is? $600 plus 400 is? Yeah, the 401st term. On the 401st term, the y power will be what? You just told me, 1 less. Now, but the x, the power of the x and the y always have to add up to what? 10,000. Okay, that's the hard part. The easy part is this. Top one is 1,000 factorial over 600 factorial times 400 factorial. That's how easy it is. Okay, let's do this. 2x minus 3y to the, let's call this 1,000,000th power. 6 zeros. Okay. I want you to find, okay, 500, I'll make it easy, and 1 term. Okay. So I want you to write out 500,000 terms before you get to the answer. Okay? Then you can find the answer. But we know this, that, remember, I've changed this into y to 1 negative 3y. So the negative 3y is my second term. Are you with me? Not just y, it's negative 3y. What will be the power on the negative 3y? 500,000. What will the power on the 2x? Notice I'm putting parentheses on those things because I just have more than just an x. So what will be the power on the 2x? 500,000 also, because these two have to add up to what? 1,000,000. So what's my factorial in the front? 1,000,000 factorial over 500,000 factorial times 500,000 factorial. And there's that term. So that means you can find any term you want